Today, we're going to pull back the curtain on the official exam mark scheme. You know, that thing that can feel like a total secret code? Well, we're going to crack it. We're going to use a real GCSE chemistry question to figure out exactly how to turn what you already know into the marks you absolutely deserve.
I mean, have you ever been there? You've revised for weeks, you know the science inside and out, but your results come back and you've dropped a mark here, a mark there. So often, it just comes down to not giving the examiner the exact answer they've got on their sheet. So what on earth are they actually looking for?
Well, today, we're going straight to the source. We've got our hands on the official AQA mark scheme for a real exam question, question 03. We're going to break it down part by part and see precisely what scores the points and what doesn't. So here's the game plan. We'll go through each part of question 3, from 1 to 4. Then, we'll wrap it all up with a full mark formula that you can use on pretty much any question. Sound good? Let's dive in. Okay, first up is question 3.1. This one was a pretty straightforward identification question, but it's worth a single, very valuable mark. And look at this, the mark scheme is crystal clear. To get that 1 mark, you had to write down either copper, zinc, or sodium chloride solution. And here's the key thing to realize, it's that absolute clarity. The examiner is only looking for one of these 3. Write down anything else, no matter how close, and just don't get the mark. It's really that black and white. All right, let's move on to the next one, question 3.2. This part asks why the reaction in a cell stops working. Again, just for 1 mark. Okay, this right here, this is the gold standard answer. The most direct, perfect phrase the examiner wants to see is a reactant is used up. If you write that down, you are guaranteed the mark. It just shows how critical those specific keywords can be. But is that the only way to get the point? No, not at all. And this is where looking at mark schemes gets really, really interesting. Examiners are often given a whole list of other things they can accept. You could have said the electrolyte is used up, or the electrode is used up. Heck, even just the reaction stops would have gotten you the mark. Knowing these alternatives gives you so many more chances to secure that point. Okay, next up, question 3.3. This one is digging into your understanding of a really important feature of the chemical reaction that's happening in the cell. So the whole concept here is that some reactions are basically a one-way street. Once the reactants have become products, that's it. You can't just flip it and go backwards. We call this a non-reversible reaction. And yep, you guessed it. Just like before, the mark scheme is incredibly specific. The exact phrase that unlocks this mark is the reaction is not reversible. You couldn't say it can't go backwards or it's a one-way reaction. Even though you mean the same thing, this is the precise scientific language the examiner is trained to look for. Seriously, precision is everything. Okay, on to the final part, question 3.4. Now this one is worth 2 marks, so the stakes are a little higher. It's all about writing and balancing a chemical equation. So, getting 2 marks for an equation like this usually comes down to 2 things. Step 1, you've got to correctly identify all the chemicals involved, your reactants on the left, your products on the right. And step 2, you have to balance it, making sure you have the same number of atoms of everything on both sides. And there it is, the perfect 2-mark answer. 2H2 plus O2 gives you 2H2O. See those big 2's in front of the hydrogen and the water? That's the balancing. Now, the mark scheme does say that correct fractions or multiples are also fine, but let's be honest, this is the simplest and clearest way to write it. But wait, check this out. This is a hidden gem from the extra information section of the mark scheme. Let's say you're in the exam, pressure's on, and your mind just goes blank on how to balance the thing. If you just get the correct symbols down and specifically write O2 as a reactant, the mark scheme says you get 1 mark. That is an amazing tip for grabbing partial credit when things get tough. So, we've totally picked apart question 3. What have we actually learned from all this? How do we turn these insights into a formula for scoring full marks every single time? Okay, let's boil it all down. First, when you revise, you've got to focus on those exact keywords and phrases. As we saw with not reversible, that precision really matters. Second, remember that there are often a bunch of different ways to say the right thing. And third, always look for those chances to get partial credit like we saw with the chemical equation. It all comes down to learning to think like an examiner. So here's the most important thing to take away from all of this. Getting good grades in an exam is a 2-part puzzle. Yeah, you have to know the chemistry, of course, but you also have to know how to communicate what you know in the very specific language the exam wants. Because the secret isn't just knowing the answer, it's knowing how to write it.